Okay, so in this video, we are going to talk a little bit about the new keyword abstract, abstract classes, and this idea of inheritance. Now, an abstract class is very similar to an interface. You can create an abstract class simply by putting the reserved word or the keyword abstract in your class definition. But an abstract class is basically a combination of an interface and a class. So you'll see I have a data member here, which I could not have in an interface because interface only defines methods. But I also have defined methods, which I can't have in an interface. In an interface, I only have methods like this that are declared but not defined. And you'll notice in an abstract class, I also have to put the reserved word abstract in with those lines. If I take it out, my IDE will think I have an error. It will say, hey, you either need to define this method or declare it abstract. So by declaring it abstract, I'm saying that there are going to be classes that extend from this file, and they will fill in the details as to how to get the area or get perimeter. So this program that we're writing is called the abstract shape class. Now, this is a good example of when to use an abstract class because while we can make shapes, we have to have a specific type of shape in order to make it. So I might be able to make, and we'll look at these later, a circle, a rectangle, or a square. And while circles and rectangles and squares are all different, all of them should be able to return their name. They should be able to set their name. They should be able to give me an area, and they should be able to give me a perimeter. Now, having a name, getting a name, and setting a name are common to all of those subclasses, all of those classes that we're going to get into. But the way that I get an area and I get a perimeter for rectangles and squares and circles are different. So I can't write the code here. Now, I could have used an interface, something like able to use geometry or something along those lines as the name of my interface, and only put these two methods. But then I'd be stuck making this data member name for every single class down the road, and that's a little bit redundant. So let's look about how this gets practically implemented looking at the circle class. So here is the circle class, and I now have another keyword reserved word called extends. So the circle extends abstract class, meaning the circle is an abstract shape class. Or sorry, the abstract shape, not the abstract class. So a circle is the abstract shape. I've added another data member here, rad for radius. Circles have radius, but not all shapes have radius. So I put it here. You'll notice also that circle has a constructor where the abstract shape class did not have a constructor. Abstract classes cannot be instantiated. I can't make an abstract shape. I have to make an actual shape, but I can refer to something in the abstract. I can refer to an abstract shape, and we'll see that more when we get into our use of these in our main method. So let's go back to the circle class. I have a data member, rad for radius, and I have a constructor circle that takes in a value in rad and sets my data member equal to it. It also calls the method setName, but you'll notice the setName method does not exist in this file. That method is inherited from the abstract shape class. Because all abstract shapes know how to set their name, I don't need to redefine that method down here. Now, I've also got these two methods, get perimeter and get area, defined now. So the get perimeter 2 times pi times the radian, the get area pi times the radius squared. These are now defined, which satisfies my duty by extending the abstract shape class. In the same sense that when I implement an interface, I have to write all those methods. If, for example, I change this name, I'm going to get an error, and it's going to say circle is not abstract and does not override the abstract methods that I inherited from above. So it's very important that if I'm going to extend from an abstract class, I actually implement the methods that I inherit. So now let's look at a main method that uses this. I have a circle C, which equals a new circle. So this is calling the constructor. I can say c.getName. Again, getName is a method that was defined at the abstract shape class. that was defined in this file. Even though it's not defined in Circle anywhere, Circle inherits that method. So all circles, because circles are abstract shapes, can also get and set names. And because those methods are public, I'm able to call them. So I can say, circle, get your name, get your area, get your perimeter. If I then run the program, you'll see that it should run and work fine. Circle, areas 50 and 25. You'll notice it's tabbed over because I use the escape character T to put a tab there. Now, I can change the way I reference this a little bit. This is the aspect of polymorphism that we'll also get to in this unit. So I can call this an abstract shape. I can refer to C as an abstract shape, and this will work exactly the same way. But what I cannot do is I cannot create a new abstract shape. So if I said abstract shape A equals new abstract shape, I'm going to get an error. And it's going to say it's abstract, so it cannot be instantiated. So it's not telling me that it can't find the constructor. It's telling me that abstract classes cannot be instantiated. So there's no way to make a shape unless, or an abstract shape, unless there are non-abstract subclasses of abstract shape. All right, so that is our first foray into inheritance. I hope that this example made some sense, and please check out the other videos to go over this in more detail.